Here we're going to do a limit that involves a little bit more factoring than our previous examples. So we have the limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4x plus 4. I'd invite you to plug in x equals 2. You will end up getting 0 over 0, which tells us we need to do a little bit more work. So the first thing we want to do is simplify, and simplifying often means factoring. So we can factor the numerator and factor the denominator. The numerator breaks up into x plus 3 times x minus 2. And the denominator is actually going to turn into x minus 2 squared. And just to make our factoring a little bit more clear, I'm going to write it as x minus 2 times x minus 2. So what we see is that we can cancel an x minus 2 in the numerator and the denominator, which leaves us with limit as x approaches 2 of x plus 3 and x minus 2. So now that we've done some cancellation, let's see what happens when we plug in 2. What we're going to end up getting is we'll have 2 plus 3 in the numerator equals 5, and we'll have 0 in the denominator. And when we get a number over 0, that doesn't mean we need to do more factoring. That just tells us right now that the limit doesn't exist. So the limit does not exist. We'll actually talk more about what we can say about this limit soon, but for right now, all that matters is that when we have a number over 0, and not just 0 over 0, that is an indication that, nope, our limit doesn't exist. And this shows us that we might start off with a case that's 0 over 0 and end up with something that's a number over 0 after doing some factoring and simplification.